Hey folks, in this video, we are going to be looking at an ERC20 contract example with Ethers.js. You can find this example ERC20 contract on the Ethers.js documentation version 5. It's version 5 right now at the time of recording this video. Now here they've given a little bit of introduction about what is meta class. A meta class is a class which is defined at runtime. So a contract is specified by an application binary interface, that is ABI, which I'm sure you're already familiar. And the ABI describes or talks about the methods and events that are a part of the contract. This description of this contract itself is passed to the contract object at runtime, and it creates a new class, which is why the definition of meta class is necessary right now, adding all the methods defined in the ABI at the runtime. However, it's not just enough to provide the ABI. It's also necessary to provide the bytecode of this contract, which is the compiled version of the contract, as well as a signer who will be signing the contract to deploy this. So the first thing that we are going to do is deploy a contract, right? We have already seen how to deploy a contract in the previous video, so I'm not going to spend too much time on this. So there's a contract factory. So you can take the contract factory, you can create a factory object out of that, and then you can use this factory object to deploy your contract. Once you deploy the contract, you will be able to get a contract address, right? So here you can see that it awaits the contract.deploy transaction. So once the deploy transaction is completed, you will get a contract address. Now that's the address that you will be using to actually interact or connect to a contract. So the next step that we'll be looking at is to be able to get the contract instance, right? You have already deployed a contract. How do you get that particular instance of that contract, right? There might be so many other ERC20s that folks have deployed, but you want to get the instance of your contract. So let's see the code. You have the ABI of that contract, which is a must-have, right? Which will have the methods and the events. And then you have the address of the contract. Now, for Ethers, because Ethers.js also allows you to use ENS, this contract address can be a hexadecimal address or an ENS name. Now, this particular contract, how do you access that? You use ethers.contract, the address of the contract, the ABI, and the provider. The provider in this case you can obtain from either your MetaMask provider or you can create your own provider by using an RPC, right? And once you have that, you can basically be able to access that contract using this particular bill called ERC20. If you use just a provider, you can do only read-only operations, right? Because a provider is just something that provides you the ability to connect to the network. However, in order to write something onto the blockchain, you need a signer. So if you use the signer and connect with the contract, then you can read and write. So you can do everything from read-only, right? And you can send transactions for non-constant functions. So you can see some of the properties that are inherited from the contract. You have the address. You can get the resolved address, deploy transaction to deploy a transaction, interface. Then you will get the API as the interface, the provider, that is the network that you're connecting to, and the signer, that is the user that will be signing, right? Now you can add certain extra methods as well, like you have the attach method, which returns a new instance of the contract attached to a new address, right? For example, if you have similar or identical copies of a contract on the network and you want to interact with each of them, right? So your provider is going to remain the same. What is going to change is the address, and the ABI is going to remain the same, right? So you can attach to another new address, and you can connect basically this particular instance of the contract, and you can return the object which is connected to the provider or signer, right? So you can also have some events, like you can have the query filter where you can return the events that match a particular event. You can have a listener count, that is return the number of listeners that are subscribed to an event. For example, if there's a swap contract or there is a liquidity pool contract, people might be constantly polling the events, right, related to that contract. So you can get that. You can get the listeners that are subscribed to an event. You can unsubscribe listeners to event. You can subscribe to event calling listener whenever the event occurs. So this is one of the interesting features. Like for example, if you want to understand what is happening with the contract, right? So you add events when there are particular functions that are being executed. But how do you subscribe to these events? How do you listen on when these events are happening or when they are getting executed? That's where you can use Ethers.js. Ethers.js provides the ability to be able to listen to these kind of events. And you can see that there's functionality like on or one when you can subscribe to the event calling listener whenever the event occurs, right? You can also remove all the listeners, see if it's your own contract. And you have a lot of other methods that are associated with this as well. So you have decimals, that is for ERC20 specific contract. You have balance of a particular owner. How much does a particular owner own? That ERC20. What is the symbol? You can transfer ERC20 to a particular account and the amount that you'd want to transfer. And you can see that you can run these kind of transactions, right? So you can create the transaction and then you can also await. Now, for a particular transaction here, you might be seeing that it is fairly straightforward, that you have like a to and then how much do you want to actually send. But you can also more complex transaction bodies. So for example, you can have like access list. You can provide the chain ID, that is to which particular provider, which particular chain should this transaction go to. You can provide data, which is actually extra information, right? You can provide from which address are you actually sending this transaction, the gas limit, the gas price. You can provide max fee per gas, you can provide the nonce and things like that, right? So you can add more things in a transaction body as well. And then you can also have like, you will need to wait for that particular transaction to go through, right? So you do await transaction.wait. You can format unit, like from way to ether or say fini or whatever it is that you're interested in displaying, the unit as. And you have a lot of other different functions and a way to handle errors that you can write as well, when you can figure out what are the type of error messages that you want to show to your user, so you can handle that. And then you have some meta class filters. So basically you can see that this is a simple example of how ethers is used to interact with an ERC20 contract. You can also see from here how useful it is to have that kind of library which can help you interact, which can help you listen to events, which can help you subscribe and unsubscribe, right, on demand to events that are happening in a particular contract. So this is Ethers.js, which is a very powerful library. Going forward in this particular module, we will be looking at certain other lessons where we are using Ethers.js in a full-fledged format, and you should be able to get a much realistic example on how to build a front end and how to integrate the Ethers library.